So I want to make a quick video on how to map out process data on IO-Link devices where it's not real cut into individual bytes, each individual byte. Sometimes process data can bleed off half a byte and then a full byte. So this is a video kind of how to explain how to get that into PLC and make it into usable data. So first, when you come into downloads, we'll go and we'll look at our IODD file or the overview, so we can really start to understand what the process data looks like and how we break that down. So I'll just come to IODD overview, and I've already got this connected to a SI-Link box over SOPUS, and you'll see that here. So once the IODD file opens up, and we can look at it and really understand what kind of data we can get over process for the process data. So once the file opens up, we can see we've got 2 bytes of process data, but this happens multiple times. And you can see these 2 bytes are different depending on which value that we have. So 16, 17, they can all be written over IO-Link with the PLC, but if you want to set up with SOPUS, this is kind of how to do it. So you can see the first one here, we really get to teach when we get Q1 and Q2. The second one is pretty much the same, so if we get a quality of alarm, again, that's a Boolean. But as we get down to the other ones down here, the difference is the measurement value that you see here. But you see this is a byte of data, and this is only 2 bits out of the other byte, right? And if you look down here, we get measurement, but it's quality of alarm. So depending on how we set this up, either in the PLC or in SOPUS, our data will look differently. So I've already got it connected over SOPUS, and we'll come down to settings. So factory default, it's going to be Q1 and Q2, and that's all you're going to get over process data. But what I really want to look at is I want to get the measurement value. Add that as well. So I want to get Q1 and Q2, and I want the measurement value. So most of the time when we're hooking up over IO-Link, we have to byte swap. If it's real clean data, then we byte swap it and we get a raw value. But in this instance, we've got a whole byte here, and we've got 2 bits out of the second byte. So let's go ahead and set up the sensor so that it is the way we want it. So measurement value Q1 and Q2, and that is the exact same thing as we see here in the IODD viewer, right? But these 2 right here are not used, so we've got to ignore those. And these right here, we also have to ignore, because that is no data is not going to come out the way we want in the PLC. So now that I have that set up, then I could teach this as well and get Q1 and Q2. If I wanted to, I've already got it taught, so you'll see those come on and off. One's inverted from the other. But you'll see that when I've got it in there, I'm down at around, I don't know, let's see, around 10. And when I pull it out, it goes up to 170. So we need to definitely note that when we hook up to the PLC. So I'll close out of this and disconnect from SOPUS. So I don't have any issues there. And I'll go ahead and connect. I'm going to connect it to pin 2 of my SIG 350. So now we can see the data starting to change on 12. So D13012. We'll go ahead and take that down to a bit level. And now we can look at this word, or these 2 bytes, and we'll see it to start to change. So we look at it, we can look at these 2 right here, and that is going to be Q1 and Q2. But the data is all broke up because it's not laid out the exact same way. So we'll go ahead and start to write a little bit of PLC program. We'll pull out that Q1 and Q2, and then we'll move some of this data around so that it's usable data. So now we'll come here. I'll go Control E, and I'll go ahead and go online. We'll make a comment so that we know where it is in the program and what port we're connected to. Since I'm using the WFS, I'll go ahead and label that. It's SIG 350, and it is port 2 that we're connected to. So now when I come back to this, if I plug something else in it, I'll know what's going on. So just write a quick little bit of code here. I'll move it from D13012 that we saw, and I'll go ahead and put it into a different D register so that I can set it up to be byte swapped. Now that we've got that data swapped, now we can start to dig everything out. But again, this is still not usable data. We've got this swapped. I'll go ahead and break out the Q1 and Q2. Now we should be able to see those go on and off. So now we can turn those on and off of our IO link, but we really want to know what the signal strength is. So I'll break those out as well. And the instruction I'll be using is XFRB. So if you want to kind of see how to use this instruction, I can come here, and what I need is a control word, a source word, and a destination word. So when I'm looking at my control word, it tells me the first letter in the command is number of bits that I want to get. And then the second one is the first bit in my destination word. And the last one is the first bit in my source word. So what I'll do is I'll come in here and just start entering that in. So this is my control word. Then we can go back to it and understand how that's broke down. So what I've selected is 0A. So 0A is 10 because I'm in hexadecimal. And then 0 because I want to start the first bit to start at the first bit of my destination word. And I want to start at the 6th bit of my source word because that's the way the IODD file is broken down. So now we've got that up, we'll go ahead and finish this up. So I've got my control word, my source word is the D1158. And then my destination would be D1160. Now we're talking about what we saw in SOPIS as far as 170 with nothing there. And that's what we see here. And when I put it in there, now it's around 12. So depending on what material I have in there, maybe if I have 2 of them, it'll change 1. Or if I want to try a different type of material, then I can detect that as well. So just depending on what I have, I'm testing. Now I can write that in the code, and it'll know exactly. I can have as many QN1, QN2, 3, 4, just depending on how many different things I want to detect. But anyway, let me know if you have any questions. I hope this helps.